Okay, and the next presenter that we have is Brohath. Are you ready? Perfect.
Can you all hear me?
Yep, we can see and hear you.
Cool, perfect. So let me just go there. Okay, let's get started. Good morning, everyone. My name is Brohath, and today I'm going to be talking about an AI-assisted dynamic quiz system for student assessments. Whether we're student or faculty, we all can agree that examinations are a painful endeavor. They are known to cause stress and anxiety to students. They're expensive to conduct because of the logistics of getting a writing space, printing papers, and grading assignments using TA. And finally, are static in nature, by which I mean they focus on the recalling ability of a student rather than their skill. In the past 2 decades, applications of artificial intelligence has gained popularity in the field of education in 3 specific areas. Starting with intelligent teaching systems, which focus on personalizing learning materials and learning strategies to students, in prediction systems, which use student data to predict their future performance and find at-risk students, and finally, in administering assessments, which involve automating sub-processes in order to give examinations. Specifically in assessments, AI has a wide range of applications. In marking, image recognition softwares are used to automatically grade essays and examinations. A common example is the use of Scantron to mark MCQ questions. A combination of image recognition and text filtering softwares are used to check for plagiarism in reports and essays. Another common example is the use of Turnitin. A back-end application for AI is using AI to classify questions automatically based on their difficulty. This can be used by professors in order to pick out questions and modify the level of the examinations that they're preparing. Although there are a wide range of applications of AI in assessments, there's limited research being done in testing the skill of the student directly. We believe this is possible by personalizing the questions students get in an examination. This leads us to our project objectives, which is to develop a dynamic quiz system that can adapt to the level of a student, and in extension, to predict the student's knowledge and skill level, to personalize questions to students, and to adjust the prediction based on their answering history. The design we propose has 3 modules, starting with the prediction module, which takes in student data, puts it against the list of questions in the question repository, and predicts the list of probabilities of the student answering each question successfully. The question assignment module then uses the list of probabilities in order to assign one question to the student. Once the student answers this question, it is evaluated in the evaluation module, and the results are sent back to student data, which then again puts it in front of the prediction module, which updates the prediction for the other questions in the question repository. The question assignment module then assigns a new question to the student. This cycle can continue until a predetermined stop condition is reached. For example, n questions have been answered by the student. And finally, the results will be posted. This summer, I've worked on the implementation of the prediction module with deep neural networks. So far, I've coded the architecture of general deep neural network. A typical representation is shown on the slide. Each deep neural network consists of multiple layers, starting with the input layer, with a few hidden layers and an output layer. The circles represent the neurons, and the arrows represent the movement of the output from a previous layer of neurons to a new layer, and also represent the weight associated with that output. A neural network works by repeating computations of the 2 equations shown below. An intermediate output of the neuron Z is nothing but the bias of that particular neuron added to the dot product of the inputs from the previous layer of neurons X with the corresponding weights of that particular output. The final output for any neuron A is nothing but the transformation of Z using an activation function. An activation function is any mathematical function which changes based on the application we're using the neural network for. In order to train, or you can say calibrate the neural network, we input it with predetermined test cases for which we already know the outputs for corresponding to some inputs. In our case, it would be to collect student data and how they've answered at least some of the questions from the question repository. The way we test the neural network is by feeding this data that we've collected and train it or calibrate it by using optimization algorithms, which finds the right values for the weights W and the biases B, which approximates the complex relationships between the input and the final output. In order to test the neural network, what we do is feed it with completely new input data for which we already know the outputs for, and we calculate the error between the actual output and the predicted output. Our goal is to minimize the error in order to improve the prediction accuracy. As with any other engineering project, this is an iterative process as we can change many parameters in order to optimize the final prediction accuracy. We continue these iterations until we reach a final desired output, which is the maximum prediction accuracy possible for the given data. The goal of the summer project was to use AI in engineering and improve the learning capabilities of students. So far, I've designed the dynamic quiz system and have coded the deep neural network architecture. This project can go beyond my summer term by collecting student data, creating a question repository, training and optimizing the deep neural network. The ultimate goal of the project is to get concrete results in the accuracy of the deep neural network in predicting the probability of a student answering a question and finding out the feasibility of the system in a real classroom. In order to define the reliability of such a system, we've defined a few metrics of success, starting with the prediction module. Since we cannot find the true probability of a student answering a question, we can say the prediction module works if it can accurately classify whether a student can answer a particular question or not more than 80% of the time. It is simpler for the question assignment module, which just needs to assign an appropriate question to the student based on the prediction module. Finally, a successful evaluation module would be able to auto-grade the questions and provide immediate feedback to the students. The overall objective of this system is so that it can be used by professors in order to find the exact skill level of student while not causing too much stress to them, as opposed to normal in-person examinations. A perfected dynamic quiz system has a high potential because of the following 4 reasons. First, it tackles the fundamental issues with examinations. Since it can be held online, it completely eliminates the costs involved in an in-person exam. Since the evaluation module can be coded to auto-grade questions, it can drastically reduce the time that feedback reaches a student, again, as compared to any in-person examination. Secondly, it focuses on the skill and the history of the student due to its adaptive nature. Each and every question is adapted or tailored to the student's skill and the way they've answered previous questions in the same topic, as opposed to the static nature of questions where every student is given the same type of questions and they answer them. Over the past few years, neural networks have shown a wide range of applications and high accuracy in each of those applications. We believe that with the right quality and quantity of data, neural networks in a dynamic quiz system can show the same high level of accuracy. And finally, this is a design or a framework that is not only applicable to engineering education, it can easily be adapted to any other STEM discipline, which shows the design's versatility. With that, I would like to thank you all for listening to my presentation, and we would love to hear any questions that you may have.
Thank you. Okay, judges.
Great, thank you very much. Super interesting research. Just a few things. How do you come to the conclusion that this would reduce stress to students? Like presumably the personalized quiz is based on a student's responses. You collect data on a particular student and then personalize a quiz based on the answers the student has provided. What in that reduces the stress of a normal kind of in-person exam?
Okay. So whenever a person is given exam, as a student, I can talk about my experience as well, is there are many factors involved when giving an exam. It could be some personal factors, the level of motivation, confidence, the amount of time they had to prepare. So when I'm saying we're collecting student data, we also aim to collect data that is more psychological, that's more demographic, which can affect a student's performance. This will be used as an initial measure in order to predict the way they can answer questions, because I believe it's more than just the knowledge level of a student that can affect their performance. And I think if we include these psychological factors, this can help the system get them questions which they will be able to answer and adapt to them as they go on answering questions. And that's where we come up with the theory that it could possibly reduce the stress that they're having, because in case of a static examination, it's just, I don't know, 10 questions the professor has already assigned, and they can change they cannot change the question once they've already put it. It could be a tough exam, they might come out bummed out, or it could be an easy exam, they'll be like, hey, it's a great exam that I just given. So yeah, that answers the question.
Thank you. Great, thank you.
Well, I can certainly see the value of research like this, and but as an educator, I may argue for a complete opposite usage of your study. For example, that if you tailor personalized quiz for the students, I think we kind of encourage them to think that along their comfortable zone. As education, I think we should stimulate to help them to learn, and something that they probably, this is what we're trying to help them to learn better, right? So what's your response to that?
Okay, this is definitely something I've considered, discussed with my PI as well. The idea behind having this type of system is to not make students comfortable with whatever they're doing, because I'll give you two responses to that. Firstly, this does not just put them in the comfort zone. In the end, it is going to be, our goal is to use this to mark students. If they answer more tough questions, then they'll get a higher mark. And the second thing is, this system, since it uses neural networks, and if it does work with its prediction accuracy and predicts the probability of a student answering a question, we can use that as a metric to adapt the system. And if we want to challenge students, then we could say the system should probably assign questions which they have a low probability of answering. For example, if we want to challenge a student, we would choose a question where the probability is like 0.2 out of 1. Right? So yeah, those are the two things that I would comment on for your question. Hope that answers it. Thank you.
Thank you.